Okay, this is the homework help for Math 3 Unit 4 review worksheet. So 1 through 15 odd, and 18 and 20 on this review. All right, so for question number 1, it says to simplify and state any excluded values. So whenever they say to simplify, that means we need to, if we have more than one fraction, combine it, factor, and then reduce. So the first thing I'm going to do is I know that I can factor a 2 out of both of those. So I'm going to do that first. So I can take out a 2 and then divide that. So that will give me x and then minus 4. And then in the denominator, I'm just going to rewrite it. So x is negative, so that's going to go first. 4 is positive, so that will go second. So again, all I did was divide out a 2 from the numerator. So 2 divided by 2 is 1x or x, and then negative 8 divided by 2 is negative 4. And then in the denominator, I just rearranged it, putting my x term first, that was negative, and then my 4 second. So I can divide a negative 1 out of both of these, right? Whenever I have a negative x term, I always want to divide out a negative 1. And so negative 1x divided by negative 1 is positive x, and then 4 divided by negative 1 is negative 1, or excuse me, negative 4. So 4 divided by negative 1. And then I want to cancel my common factor, so they both have a x minus 4 common, so I can reduce that. And I'm left with 2 divided by negative 1, which is negative 2. And then for my excluded values, x cannot equal 4. And for that, we're looking in the denominator, right? So I'm looking in the denominator for my excluded. So I have a negative 1 in the denominator and an x minus 4. And then I'm not going to set this equal to 0 because it doesn't have a variable. So here I would have x minus 4 equal to 0, add the 4. So x equals 4. So my excluded value is 4, so I can't use 4 because if I did, I would be dividing by 0. All right, so let's take a look at question number 3. So for question number 3, I can take out a GCF, so I can pull a 2 out of both of those. And then in the denominator, they all have an x common, so I can take an x out of all of those. So I divided a 2 out of 2 and negative 32, which gave me 1x squared and negative 16. And then all of these had at least an x in them, so I took the x out, reducing each one. So the numerator is a difference of 2 squares, so I can factor that. So I have 2 terms of binomial that is subtracting and perfect squares. So the 2 is still here, and then this will break up to x plus 4 and x minus 4, right? Because 4 times negative 4 is negative 16. And then for this one right here, if I were to list my factors on that, so I'm going to do that on a separate piece. So this is a trinomial that's squared. So my factors for x squared are x and x. My factors for 8 are 1 and 8, or 2 and 4. And I know I need to have a positive 8 when I multiply, so both are positive because this is also a positive. And then the pair of terms that will work to give me a 6x is when I multiply 2x and 4x. That will give me 6. And I think I just said that weird. So when I multiply x with the 2, it gives me 2x, and when I multiply x with the 4, it gives me 4x, and it will give me 6 when I add. So I still have this x out front. And then my grouped factors are going to be 2 and 4 with x and x. So I can cancel any common factor, so that would be x plus 4 is common, and then that's it. So I would have 2 in the numerator and an x minus 4. And in the denominator, I have the x and x plus 2. And then for my excluded values, I want to get that from my original factor denominator, so from here. So I know x cannot equal 0, -2, and -4. So there's my reduced fraction and my excluded values. And just to make sure, I'm going to do this part on a separate piece here, so I'm going to do that over here. So here I would have x equal to 0, and then on this factor, x plus 2 equal to 0, and then x plus 4 equal to 0. And then when I go to solve this, I would subtract 2 from both sides. So then x equals -2, and then over here subtract 4, so x equals -4. So that means x cannot be 0, -2, or -4, because then I would have a 0 in the denominator. Okay, so for question number 5, lots of different ways to do this problem. Okay, so when it says to multiply, I'm just going to extend this like it was one fraction. And then I'm going to combine my numerator and combine my denominator. So 3 and 9, and I'm multiplying, so that would be 27. And then in alphabetical order, I have 1x here and 2y, so y squared. And then in my denominator, I have 4 and 12, so that would be 48. And then x to the third and y. And then when I get here, I want to try to reduce this. So I know for sure I can divide out, I think a 3. So yeah, I can divide by 3. So I'm going to do that. So divide by 3, divide by 3. So 27 divided by 3 is a 9. And then 48 divided by 3 is 16. So I have 1x in the numerator and then 3x's in the denominator. So this x will cancel completely, taking 1 off of that. So that would leave me with x squared. And then over here, this y will cancel completely, taking 1 out of here, leaving me y to the first. And then do a quick check, and then I know 9 and 16 won't reduce any further, so then that is my simplified fraction. Okay. All right, and then let's take a look at number 7. So for question number 7, I have a trinomial with a squared term. They have nothing common, so that means I need to list my factors. I'm going to do that one upside down. So x squared is x and x. And then for 10, it could be either 1 and 10 or 2 and 5. And I know one of these has to be negative to get a -10 when I multiply. And then the pair that will work for a -3x will be the 2 and the 5, because when I subtract, I'll get a 3. And then if I want a -3, then that means I want 5 to be negative. So that would be -5x and 2x for a -3x, and -5 times 2 is -10. So for this group down here, I want to do the same thing. So for x squared, x and x, 4 is either 1 and 4 or 2 and 2. And in order to get a positive 4 when I multiply, they either are both positive or both negative. And since my middle term is negative, they both have to be negative. And so -1 and -4 won't give me a -4, so I know it's -2 and -2. So for factoring, so for the numerator, I have x and then -5 and x and plus 2. And then for the denominator, I have x minus 2 and x minus 2. And again, if I wanted to check that, that would be -5x plus 2x, which is -3x, -2x, and -2x is -4x. And then for the second fraction, I have a GCF of a 4, so I'm going to pull a 4 out. And down here I have a GCF of a 2, so I'm going to divide a 2 out. And then as soon as I have it completely factored, I'm going to extend it so it's one fraction. And then I can cancel any numerator factor with any denominator factor. So the x minus 5's reduce, and an x minus 2. And so 4 divided by 2, that will reduce as well. So 2 goes into 2 1 and into 4 twice. So for my numerator, the only thing in here is a 2 and an x plus 2, and then to have it in the right order should go 2 first. And then for the denominator, I only have the x minus 2. And so there's no other common factor, and so that's my final answer. Okay, let's take a look at question number 9. So for this one here, I'm going to flip this around because I want my x term first. So x squared is negative, so that should be negative x squared. And 4 is positive, so positive 4. And then for the denominator, nothing will divide out of both of those, but I can always pull out a 1. And then that's not a factor, that needs to be factored because it's just 12x by itself. And then here I can pull a 3 out of both of those. So now for this I have a negative, so I'm going to take out that negative 1 because I always want my leading coefficient to be positive. So that would be a positive x squared now. And then 4 divided by negative 1 is a negative 4. And then one more here. So I know x squared minus 4 is a difference subtraction of two perfect squares. So that will factor one more time. So I will have negative 1, x plus 2, x minus 2. And then once I get to here, I'm going to make this as one fraction here, like a multiplier. And then as far as canceling goes, I know the x minus 2's will cancel, as well as the x plus 2. And I know even though it's written as 12x, it's the same as 12 times x. And then 3 divides into the 12 4 times. So then in my numerator, I'm left with negative 1, 4, and x. And in the denominator, I have a 1 and nothing else. So negative 1 times 4 is negative 4, and then x, and then over 1, but I don't really need to do that, right? So that's just the same as negative 4x. Okay. All right, and let's take a look at, oops, you couldn't see that last time. There you go. Okay, and then let's take a look at question number 11. Okay. So I'm going to do the factors on a separate piece over here because this is a leading coefficient. So I have a trinomial, so 3 terms, and I have no common factor, so I can't divide anything out of all of those. So then I have to list my factors. So for 10x squared, it's either 10x and 1x or 5x and 2x. And then the only way to get a 1 is 1 times 1. And then I know one of them has to be negative, right? Because otherwise I can't get a negative 1 when I multiply. So now I need to figure out what pair will give me a 3x. So if I take a look here and multiply, that gives me negative 10x and 1x. So 10 minus 1x, which is a 9x, so that won't work. So this time I'm matching this pair over here now, right? And so here this would give me a 5x and a 2x, and a 5x and a 2x will give me a 3. So if I want to get a positive 3, should it be negative 5x and 2x, or the reverse? And it should be the reverse, right? I want the 5x to be positive. So that should be multiplying like that, right? So 5x minus 2x is 3x. Okay. So that'll be my pairs. Let me pull that away. So over here, so I have a 3x plus 2, and I can always take out a 1, right? And then here I can take out, looks like an x. So that will leave me with a 5x minus 1. And then over here, I'm using the pair that I came up with, right? So this pair down here. And then do a quick check, so that would be positive 5x minus 2x, which is 3x. Okay, good. And then now for this one here, I also have a trinomial and no common factor, so I'm going to list my factors on that. I'm going to do it on a separate piece again. So 6x squared could be 6x and 1x, or 2 and 3. And then the only way to get a 2 is a 1 times 2. So I know one of them has to be negative, right? One of them has to be negative, so either the 1 or the 2 is negative. To get a negative when I multiply, so that means I'm going to end up subtracting. So if I look at this pair, I would get 6 and 2, so 6x and 2x, which won't give me a 1x. So here I have a 2x and a 6x, so 2 and 6, which won't give me 1, but if I flip it, I'll get a 4 and a 3. So here that gives me 4x and 3x, right? And in order to have a positive 1, I need my 3 to be negative, right? So negative 3x and 4x, so 4 minus 3. So there's my pair. So again, the 2x has to multiply to positive 2. Whoops. And 3x to the negative 1. Okay. All right, so do a quick check. So that would be 4 minus 3, which is 1. Okay, so now for canceling, the 5x minus 1 cancels, and the 3x plus 2 cancels. And that looks about it. So in the numerator, I'm left with a 1 and a 2x plus 1, but I don't really need to write the 1. And then in the denominator, I have the x and 2x minus 1. And then these won't reduce, right? Because those are different. And that's it for number 11. Okay, so now let's take a look at question number 13. So for 13, they just want us to add or subtract, and the good news is I already have a common denominator. So in this case, I want to add with a common denominator, so that is a lot easier to do, right? So then I'm just looking what can I combine in the numerator, and so it looks like I can combine the negative 17 adding 2, right? So I have nothing to combine with a 5x, and then negative 17 plus 2 is negative 15. And then over the same denominator, so don't do anything to the denominator, it's already matching. And then once I get here, I want to try to factor, so I know I can take a 5 out of the numerator, so I'm going to do that, so I can divide out a 5. And then for the denominator, I have a trinomial, right? So 3 terms, and they have nothing common, so that means I'm going to list my factors. So for x squared, it's x and x. And then 24 is 1 and 24, 2 goes into it, 3, 4, I think that's it, yeah, okay. And then in order to get a negative 24, when I multiply, one of these numbers has to be negative. So to get a 5x, so if one has to be negative, I'm subtracting. So it looks like 3 and 8 will do that for me, right? So if I do 8x minus 3x, I'll get a positive 5. So I want my 3 to be negative. Okay. All right, so my factors are x minus 3, and x plus 8. So 8x minus 3x is 5x. So that cancels, and then I have a 5 in the numerator and x plus 8 in the denominator. Okay? All right, and then let's take a look at question number 15. So for this one here, I have to get a common denominator, right? I have to get a common denominator. So I want to look at the first denominator, which is a 3a, and then the second denominator, which is a 6a squared, kind of squished in there. So I know that 3 goes into 6, so I don't need to have the 3, right? Because it's already as part of the 6. And I know that a goes into a squared, so I don't need the a. So it looks like I can use 6a squared as my common denominator. So I have 2 over 3a. And if I want that to be 6a squared, I need to multiply by 2a. Right? Because 3 times 2 is 6, and a times a is a squared. So my second fraction, I already have 6a squared, so I'm really just going to multiply it by 1, or it's not really changing there, right? So now I have a 4a in the numerator, 2 times 2 is 4, and 3 times 2 is 6, and then I have 1, 2a's, so a squared, and then that's just going to stay the same. And then as soon as I have a matching denominator, I need to just combine. And so I have nothing to combine in the top right, because 4a won't combine with 5. So it would just stay 4a plus 5 all over the common denominator of 6a squared. Okie doke? Okay. So now you might have done this problem a little differently, not noticing the common denominator to be that, which is fine, right? So let's say that you saw the common denominator was 3a times 6a squared. So let's say you just thought it was 18a cubed. Like that will work as well, right? 18a cubed will work just fine. So when you do that, you would have 2 over 3a. So then you would have multiplied by 6a squared. And then will that give you the same answer as me? Of course it will, right? You're doing nothing wrong when you do that. And so on this one, you would multiply by 3a, right? So it would look like that. And so then you would have 2 times 6 is 12 over 18a to the third, right? So 3 times 6 is 18, and then 1, 2, 3a's. Here you would have 15a. Over 6 times 3 is 18, and then a to the third. Right? So now you have a common denominator, so you can combine your numerators. And so actually nothing combines, right, because you have different terms. So far so good. And then now you would try to factor, so I know for sure I can take an a out of both, and what else? How about a 3? I think I can take a 3 out. So how about divide out of 3a? So that would be 12 divided by 3 is 4. And I'm taking one of the a's. 15 divided by 3 is 5. And I'm taking away the only a. And then I would have 18 over a to the third. And then once I get to here, I can reduce, right? 3 goes into 18 6 times. And then I'm going to take away one of those a's. So that would drop it to the squared. And 4a plus 5, which is the same answer I got doing it the other way as well. Okay? All right. And let's do 2 more on this video. So this is question number 18. So the first thing I want to do here is I want to get this in the correct order, right? So I have a 4 and a negative x squared, so I want to flip that around before I do anything else. And I'm going to make that add the opposite. And so once I get to here, I want to factor out the -1, right? So that I get my denominators factored. And I'm not going to factor that guy just yet. Okay. All right, so all I did was turn this around, right, because these are opposites of each other. So I made the -x² come first and the +4 come second. And then I want to take out the -1, so I can divide out a -1 here and here. And then I can look to say, okay, these denominators are almost the same. This guy's missing a -1. But also if I look here, I have a double negative. So I'm actually going to take a little shortcut here, and I'm going to say a double negative turns into a positive. So really when I have this problem, I've got x² over x² minus 4 plus, now this turned into a positive 2x, and then that 1 is divided away. And so I don't need to have the 1 in there anymore, so then I just have x² minus 4. So taking that little shortcut saved me from really having to find a common denominator, because that -2 and -1 turned positive. And so now I have a matching denominator, so I just need to combine. And so then I'm going to just go up here. So I'm adding, I can't actually add those together, so I would be left with x² plus 2x over the matching denominator of x² minus 4. So remember, our goal for adding and subtracting, you need to combine your fractions and then try to simplify. Some of you are trying to simplify as you go, but you need to have that be your last step because you need a single fraction to factor. So now that I have a single fraction to factor, I can take an x out of both of those and then factor my denominator. And then the x plus 2 is canceled, and I'm left with an x in the numerator and x minus 2 in the denominator. Okay? All right, we're going to do one more problem here, and then I'll do the remaining review questions on a separate video. Okay, so let's take a look at question number 20. So for question number 20, I'm going to actually do this one on a separate sheet of paper, only because it's going to take up a little bit more room than I left myself. So for this one right here, again, I'm going to do it on a separate piece of paper, so I'm going to take this away. So for question number 20, I have different denominators and then nothing factors. So I look at both of these denominators here, right, and I have nothing that is common. So for my LCD, I have my first denominator, which is x plus 1, and then my second denominator, which is x plus 4. So then that's my common denominator. So my goal is to subtract these two fractions, not solve anything. So because I'm not trying to solve, I need to make my fractions balanced, not my equation balanced. So if I want my fractions balanced, I need matching denominators. Not trying to get rid of my denominators, I need to match my denominators. So that means on this one here, I need to multiply by x plus 4 to the numerator and to the denominator. Why? Because I'm trying to get my fractions having the same denominator, not get rid of my denominator. And so then this one here, I need to multiply by x plus 1 to the numerator and the denominator, right? So I'm keeping my fraction balanced. And then from here, I need to go ahead and simplify. And remember, whenever we have a subtraction, you want to add at the opposite, right? Do the plus -5 so you remember to distribute the negative to everything. So here I want to distribute the numerator. And distribute over here -5. So now again, my goal is to get a single fraction, then try to simplify. I do not want to simplify right now. I want to get a single fraction and then simplify. So I have a 3x plus a negative 5x, so I want to combine those. And then I have a 12 with a negative 5, and I want to combine those. So that would give me negative 2x, and then 12 minus 5 over the common denominator. And then I can factor nothing out of the numerator, so then that is my answer. Okay? All right, and that's it for this review video.